So we have an inequality to solve here of x squared is less than or equal to 3, and we're going to use a 1-2 chart approach to help us solve this inequality. We begin by subtracting the 3 over to the left-hand side to get to x squared minus 3 is less than or equal to 0. And then we pretend for a moment that this expression we are now relating to 0 of x squared minus 3 actually equals 0. If we let it equal 0 and we solve for x from there, well, we would add 3 over. Since it's x squared would equal 3, we would have to take the square root of each side. And as you take the square root of each side in any equation, you got to remember the plus or minus aspect that comes into play. We would get x equals plus or minus root 3. Now this plus or minus root 3 is key here because this helps to set up our boundaries, if you will, for the intervals that we want to use on our 1-2 chart. So as we go to our 1-2 chart, we've got 2 columns. One column devoted to all of our potential x values that could make up our solution here for our inequality, and another column that is compared to the expression that we set less than or equal to 0 over here in the first place. So that expression is x squared minus 3. In setting up the intervals, we start at negative infinity. We work our way up to negative root 3 because negative root 3 was the smaller of the 2 values we found over here for x. We stop at negative root 3 and we acknowledge what its value would be as we compare to the expression x squared minus 3. Of course, that would be 0. That's how we found negative root 3 in the first place. We then go from negative root 3 up to the next value that we found for x. That would be the positive root 3 from over here. At root 3, just like at negative root 3, our expression of x squared minus 3 would be 0. And then we got a little typo here on the last interval, but on the last interval we would go from root 3 up to infinity because basically we have no more solutions for x that we have to consider. So at this stage in the game, what you do is you select numbers on each of the intervals that we found over here. And as you take those numbers, you plug into the expression x squared minus 3. So say I take a number on the interval negative infinity to negative root 3. So I choose negative 10, for instance. That would be less than negative root 3 for sure. I plug in negative 10. Well, negative 10 squared would be 100 minus 3. Well, that'd give me a positive result. So that's where this little plus sign is coming from. If I go down to the next interval, negative root 3 to root 3, and I choose a number there. Say I choose 0. If I choose 0 and I plug in, I'd have 0 squared minus 3. Of course, that's going to give me a negative result, so that's where this little negative sign is coming from. And then on my last interval, the root 3 to infinity, choose a number that's larger than root 3, something like 10. If I plug in 10, well, obviously if I plug in 10 here and I figure out this expression when x equals 10, I'd get a positive result back. Once you identify the signs for all of your intervals, you're ready to determine what your solution is going to be for the original inequality of x squared is less than or equal to 3. In this case, x squared minus 3, this key expression we've been using here as we've been plugging in values, has to be less than or equal to 0. Well, for a number to be less than or equal to 0, it would have to be a negative value. So the only negative value we got back was for the interval negative root 3 to root 3. So that's why you'll see in our solution set we've included that interval. Now the reason we're using brackets on that interval is because we're talking about it being less than or equal to. So it could equal the negative root 3 and it could equal the root 3 over here, so we have to use the brackets to include those both. Had this just been less than, well, we'd use parentheses down here because those roots would not be included.